All right, we are in AP Calculus. Today's date is Monday, January 27th, 2020. Make sure that this thing is fitted correctly. So 127, make sure your name and date are on your paper. What is our objective for today, Claire?
Find the absolute extrema for differential equations.
There it is. And this is basically the same thing that we've been doing before. Absolute extrema is finding where the particle is farthest, where and where?
Right, left.
Yeah, exactly. So finding where a particle is farthest, left or right. And you've done those problems before, and that means you're going to be making a table, and that's the last part of the speed sheet that I just added today. All right, I need a reader. This is our last lesson, yeah. 8-4, and then self-check, self-check, self-check. We have 6 self-checks. Pre-test is on Friday, which means fix-up is on Monday, test is on Tuesday. We're all okay on that?
Mm-hmm. Today for the regular calculus is fix-up, right?
Yes,
Okay.
for pre-calculus, fix-up, and then test is tomorrow.
And on Thursday, Stan and I are going to be on.
Where are you guys going? Mock trial. Oh, yeah, that's right. Do you know anything about Colville?
Ready.
Do you know how Colville's doing? Are they ready? Are they going to...
Well, we don't even know who's in it. We asked the AP history class if any of them were in it. None of them were. So it's probably made up of 5 freshmen who are doing 15 year old each.
Ooh, that sounds rough. Sorry, Colville. All right, so, Gio, do you want to read for us?
On a chilly Saturday?
Yep.
On a chilly Saturday morning, a weather tower in Davis starts with 1,200 gallons of water. Water enters the tank at a rate of W, where W T equals to 90. Yeah, you got it. Water leaves the tank at a rate of R, where R is a negative rate. I know that. Both W and R are measured in gallons per hour.
Keep going, yeah. When does
the maximum amount of water occur on 0 graded
less than or equal to?
less than or equal to T less than or equal to 18? What is that amount?
Perfect. So I've already given you some nice graphs. Unfortunately, we are going to need to graph these on our own as well because we need to figure out what these points are actually intersecting. So obviously, if I'm going from a from a negative amount to a positive amount, is that going to be a minimum or a maximum?
Positive 200.
So this is a negative height to a positive height. Therefore, this is going to be a,
Minimum.
label it, that's a minimum. A positive height to a negative height, label it as a
Max.
maximum. So we could either have a maximum at the initial value or at this value. We know that it could be here because this negative area and positive area, they kind of cancel each other out. You can kind of just tell by the graph that this area is more area than the negative area, therefore the maximum is probably going to be right there. But we still need to calculate what that point is exactly. So we're going to put these equations in our calculator, subtract the positive rate, as Gio said, do positive rate minus the negative rate to get this this black equation down here. Essentially the blue equation minus the red equation. So let me pull up my calculator emulator. File, open my TI-83 Plus. So Gio and Arrow are doing something similar. Make sure you have Y1, Y2, and Y3. Do that silently up here because I know I'm starting to annoy people by saying things.
To do the square on the sign, that's just after.
Exactly, yeah, square after.
That always confuses
It's so confusing. This
3.
Yeah, thank you for getting us the super fancy things that make it super easy.
Yeah, and that was John who really said I should push for that, and I did, and I used up half of my money for the entire year just buying those calculators. So when you hear other, it's true, but when you hear other classes saying well, why don't you have enough whiteboard markers this year? I'm like, calculators. I bought a lot of really nice compasses that ate into my budget.
The compasses have been being weird because I keep trying to borrow them to use them for stuff, and the piece that holds, they are good at holding the things they're supposed to hold.
the metal tips?
The metal tips will always fall out, and then the lead
They shouldn't be.
will
If,
also always fall out.
if the metal tips are falling out, that's a problem, and I need to super glue those in because there's not a point in removing them. I've super glued like 4 of them already. So if you find one that's not doing well, just give it to me and be like, super glue
Okay,
this.
sounds good. That
If the
would
pencil's
solve
falling out, we can just replace the lead.
Yeah.
All right, so we have y1 minus y2. Everyone has the correct functions in their calculators. We should graph y3 now. So make sure that you're hovering over y2 and hitting enter, hovering over y1, hitting enter. So you're only graphing y3. Our window is going to be between 0 and 18. So 0, enter, 18, enter. And we can actually graph what that point is going to be. So I'm going to do
It's really cool when you have all 3 functions.
zoom 0. Yeah, and then you guys that have the fancy colored ones, it's really easy to distinguish between the two.
It's loading.
On the TI-83 pluses and on the TI-89s as well, you can hit up and down to toggle between the functions. So there is our black function right there, as it appears on the TI-83 plus. And I need to figure out what this point is. I guess I should figure out this one too, just in case I didn't know, right? If you don't know if it's a relative extrema that's a minimum or a maximum, just find all of the relative extrema, find all the critical values, and then you can't go wrong for your table that's going to be on the back side of your paper, right? So I'm going to find this point first, which I know I don't actually need to find since that's going to be a minimum. So if you want to save work on the actual AP test, skip that one. You don't need it. You just need to find the maximum. So let's do second trace to calculate these zeros, hit 2. And my left boundary, I'm going to guess, you can even see on this graph, it's between 6 and 7. So I'm going to say between 5 and 9, and I'm going to guess 8. It's a really bad guess, but it'll still get me the right answer of 6.495. So I'm going to say 6.495 on this graph, and then finding the other one, so it's second trace to calculate these zeros, and I'm going to guess between 12 and 14, and I'm going to guess 13, and I get 12.975. 12.975.
It bothers me when they're so close to a number that makes a lot of sense. And they're just so far, you know? Like that's almost 13 and the other one's almost 6.5.
Right.
But it's not.
It's off just by a little bit, by a hair. Yep. So we can't even answer this question A technically until we show our work on the backside. So on the backside, again, whenever you have a question that's asking for farthest to the left or the right for particles, or if you're talking about maximum or minimums when they give you a differential equation, you need to make a table with start plus change. So start plus change. Every single time, maximum or minimum, a table of start plus change values. What are the 3 things, if you don't know about mins and maxes, the 3 things you will always check over and over again? First, start, and our start was 0. Second, our endpoint, yeah, that's one of them. Our endpoint was 18 in this case, so I'm going to come down here and say 18. And the third thing that we need to check are all your relative extrema. I'll make a note here. All your relative extrema, I can't spell E-X-T, extrema, are in this area right here. And relative extrema, the definition of that is where do you have a sign change for your rate. And this is a graph of your rate. So there's a sign change right here at 6.495 and a sign change here at 12.975. So I'll say 6.495. I maybe should have shifted this table a little bit to the right. And 12.975. 12.975. And then you're going to do your start plus change equals n. So what is our start? 1200. So you can come up here and you can label that as our start condition. Our start is 1200 or 1200. So 1200, 1200, 1200, 1200, and then we're going to do change. That's the integral from our start time. Our start time tells us our start time is 0. So our start time on each of these integrals is 0, plus the integral from 0, plus the integral from 0, plus the integral from 0 to whatever time I have on the left-hand side. So from 0 to 0, from 0 to 6.495, 6.495. 495, there we go, and 12.975, and 18. Of what? Of this function W, capital W minus capital R. So I'm just going to say, abbreviate capital W minus capital R, capital W minus capital R, capital W minus capital R, and finally capital W minus capital R. I'm being informal here, so technically I should have W of t minus R of t in parentheses, all of this dt, but I'm not, because it doesn't really matter that I'm being formal. I'm just kind of showing my work what my thoughts are. These are going to be your end values. Of course, integral from 0 to 0, just cancel that out. I'm left with 1,200. You don't need to calculate this one because we know that's going to be a minimum value, but I'm going to just for the practice. So the way that I do that is I get out of my graph and I can say, or you can do it with the graph, right? You can do the second trace and you can do the calculation of the integral using the 7, but it's faster to not do that and just do math 9, vars right, enter 3, the y3 function with respect to x from 0 to 6.495. 6.495. And then I need to add 1,200 to whatever this answer is because I need to include my start condition as well. It's a very common mistake to just forget your start condition after you do your integral. So don't feel bad. Okay, so I have a negative amount, and if I add that to 1,200, I get 525.242. 525.242. And then I have to do the same thing again, so second enter to go backwards between 0 and I can replace this with 12.975. Enter, wait for it to do this thing. Use your shortcut keys. Second enter will do the last entry and then the last entry again. So second enter will go backwards 2 steps. You got this. Go, calculator, go. Did someone already get this?
No, it's still there.
Okay, I got
Wait, which one around? The third one?
I got 497.441, and then I need to add that to 1,200, so 1,697.
Wait, I got 494.
Oh, really?
Yeah.
12.975. Can you try one more time to just verify, or if someone can verify my answer or her answer?
I got, or altogether with the 1,200, 1,697.441.
Yeah, I guess so. It confirms. Claire, you might want to retry it and see what happened. And then finally I need to do second enter again and change this into, we'll hit delete. Delete will get rid of all of your stuff in there without clearing the entire line, and change this to an 18. Yeah, delete. If you hover over anything and hit delete,
Wait, where's delete?
delete is to the left of the left key, or to the right of the mode key.
Oh, that might be really important.
Yeah, so you can delete entries without clearing the entire line.
Okay.
And 109, so that's going to be 1,309. 1,309.788. 788. And it's pretty clear from our graph, if we're being very analytic about a graph, that this area, this positive area, is bigger than the negative area, therefore the maximum has to happen at that time. So just from the graph, you could kind of explain, if you forgot all of your other mathematics, you can say, well, the area between 0 and 6.495 is less than the area of 12.975, therefore the maximum has to occur at 12.975. That's a good explanation, but even better is just making this table and saying, hey, these are all the possible values, these are all the relative extremas, therefore the answer, or when the time happens, because it's asking both, right? Part A is asking when does it happen and what is the amount. It's asking both. So it happens, I'll type this in here. Change this to blue. So maximum occurs at t is equal to 12.975. 12.975 with I'll just say the amount 1,697. 1,697.441 gallons. And it's measured in gallons, right? Yes, I didn't just randomly assume that.
Wait, do we have to have gallons? I mean, units per time?
It doesn't hurt.
Okay.
Is that gonna make this all funky? There it goes.
Except for that we're not giving
Yeah.
We are, yeah. So it says measured in gallons per hour right here.
Oh, gallons per hour.
Gallons per hour. Perfect. And that is how you do our table with our new unit. All right. Ask me questions. Okay, it's very, very similar to our last unit. Yeah, if there are no questions, give me at least a fist of 5 on how well you can do this objective. 5, 3.5, 3, and 4, right arrow? All right, cool. Yeah, that concludes this lesson.